this question here. Shown that f of x is equal to ax squared plus bx plus c. Prove that if x1 is equal to alpha and x2 is equal to beta are the roots of f of x, then the sum and product of these are given by alpha plus beta equal to negative b over a, alpha beta equal to c over a, respectively here. Now, when we say roots of f of x here, we simply mean that these are the answers to the expression that we have there. So meaning that here, if we have x1 being equal to alpha and x2 being equal to beta like this here, it simply means that these are the roots of the equation that we have here, such that if we plug these roots into the expression there, this will be equal to 0 here, meaning that ax squared plus bx plus c will be equal to 0 here. Meaning that if these are the roots here, then while there's x here, we substitute with either alpha or beta. They just represent numbers. So if we sub those numbers into this expression here, it's going to give us a 0 this side here. Now, I'm going to say this is x equal to alpha and also x equal to beta like this here. Now, remember when you're solving a quadratic equation here, if we push this the other side of the equal sign, we also push the alpha the other side of the equal sign, we're going to have x minus alpha is equal to 0. So let me just erase that. Okay, so we're going to have x minus alpha this side will be equal to 0. Then we also push this the other side, we're going to have x minus beta here is equal to 0 here. Now, these being the roots of this expression that we have here, in factored form here, we're going to have x minus alpha, we close here, and also x minus beta here, this will be equal to 0 like this here. Okay, so let me just write that nicely again, sorry about that. Okay, so we're going to have as well as x minus beta is equal to 0 here. So this is when these are the roots of this expression here, of course they are going to give us a 0 just like that. Now, remember, we have the expression that we have, which is f of x here, f of x being equal to ax squared plus bx plus c like this here. Then, this in factored form, where it's not equal to 0 here, we're going to say in factored form, this becomes f of x equal to, we multiply this by a constant a that we have, x minus alpha, and also x minus beta like this here. The reason why we're doing this here is simply because we're adding this coefficient a that we have here, so that the equation doesn't lose meaning when we compare to what we have this side here. Now, we're going to expand these brackets that we have here. So we have a, open brackets, x times x, we're going to get x squared. X times negative beta, we'll get negative beta, x like this here. Negative alpha times x, we get negative alpha x. The negative alpha times negative beta, we're simply just going to get a positive alpha beta like this here. Okay, so we continue there. We have our a outside here, open brackets, we have x squared. Then when you look at these two terms that we have here, negative beta x and negative alpha x here, they have something in common, which is negative x. So we can just factor out the negative x there. So we're going to say minus x, open brackets, alpha plus beta plus alpha beta like this here. Then we multiply this coefficient a that we have here, or this constant a that we have here, throughout the expression that we have. We have ax squared minus ax, open brackets, alpha plus beta plus a alpha beta like this here. Now, remember we have two expressions here. We have now that f of x here is equal to this, and f of x this side is equal to this here. So we're just going to compare the two functions that we have, and then we equate the like terms together there, because f of x is equal to f of x here. So now here, one function that we have here is f of x is equal to ax squared minus ax alpha plus beta plus a alpha beta, like this here. Then the same function f of x here, in the question was given to say we have ax squared plus bx plus c, like this here. Now from this here, you notice to say that the first two terms here are equal there. If you look at this, meaning that these two are supposed to be equal and these are supposed to be equal as well here. So we're saying ax squared is equal to ax squared, like this here. We've shown the first part here. We're going to have x squared will be equal to x squared this side. Then negative ax, open brackets, alpha plus beta here should be equal to bx that we have here, because it's the sum that we need there on the middle. So we have like this. Then we divide by negative ax. We also divide by negative ax, like this here. So this side will cancel. We're left with alpha plus beta. We're left with alpha plus beta is equal to x, and x will cancel there. We have negative b over a, like this here. Then we do the same thing. We have a alpha beta equal to a constant c that we have here. So since we need the product, which is alpha beta, so we divide by a, we divide by a both sides, and then we have that alpha beta is equal to c over a, like this here. Okay, so therefore we've shown to say that the sum of that expression that we have, which is alpha plus beta, is simply equal to negative b over a, and also alpha beta is equal to c over a, like this here.